Hello everyone, welcome to NetSecure Insights. In previous video, we have learned what are the types of network and what are the expectations of network. If you have not watched that video yet, please go and watch so you can understand today's topics. The links for the last two videos are in the description. Okay, coming to today's topic, I will explain you what is a data center, rules of communication in networking, some network protocols and their layers. Guys, please watch this video till end without any deviations because this is an important topic for the networking and security. And feel free to comment down if you have any questions related to today's or any previous topics. So let's start with today's first slide, which is data center. A data center is a facility used to house computer systems and associated components. It generally includes redundant or backup power supplies, redundant data communications, and various security devices. So, devices like servers, routers, switches, firewalls, etc. are kept in a isolated room, and that room is called as a data center. Let us know what these all devices are used for. First is servers. Servers are storage devices where all the important data is stored, like any company's sensitive data, your browsing history, your account passwords, etc. Next is routers. These are the main internet connection gateway devices. These are used to connect the private network to public network. Next is switches. These are primarily used to connect multiple devices to each other. As we discussed in previous video, to connect multiple devices to each other physically, switches are used. This is a switch. These are the three computers, and we connect them to the switch so that they can be connected with each other. Then comes firewalls. These are the major network security devices used to secure the organization's network. Okay, don't worry, we will learn all of these devices deeply in our upcoming videos. The above image you see is the architecture of the data center. This is how it looks. And the below image is the visual representation of the data center. So to protect all these devices, data center are built and only few authorized persons are allowed in the organization to access this room. If you are working in an organization, you will understand what is a data center. Let's jump to our next slide. Communication needs rules. So in networking, rules for any communication is a protocol. For example, if you see human communication components, you will understand this. First component is sender and receiver. Just like you need at least two people to talk, whether on the phone, in person, or through messages, there is no point in talking to yourself, right? Similarly, in networking, you need a sender to send the data and a receiver to receive it. Second component is method of communication. If you are communicating with someone on WhatsApp, that's the method of communication. Using a regular phone or speaking face to face are also methods. So if you are messaging on WhatsApp, the sender and the receiver should both communicate using WhatsApp. What would be the sense if you text your friend on WhatsApp and they reply on mails? There is no point, right? Thus, in networking, the protocols you use for communication, the sender and receiver both should use the same protocol. Do you get this point? Third component is common language and grammar. If you are speaking in English and the receiver responds in the French or German, how will you communicate? Likewise, in networking, both parties should use the same transmission medium. Like it should be a fiber to fiber or Ethernet to Ethernet or wireless to wireless medium only. Fourth component is speed and timing. Suppose you are watching this video, go and increase the speed to 5x. Will you understand anything? No. Also, if you start watching from the middle, will you understand the entire video? No, you will not. Like that, in networking, the reply from the receiver should come in time and with accurate speed. Fifth component is confirmation requirements. Imagine you ask a question to your friend and they walk away without answering. You would be upset, right? Similarly, in networking, if a device doesn't receive an acknowledgement from the receiver for your request, the communication won't happen. I hope you understand all these aspects now. Now let's come to our next slide. Protocol, proprietary and standards. What is a proprietary? Proprietary protocols are developed by a single company or organization and are typically used within their own products or services. For example, in the past, many companies used proprietary protocols because they offered control over how their systems communicated. For instance, early networking equipment often used proprietary protocols that were specific to their manufacturer's devices only. Like in past, if you buy a Fortinet firewall, you have to buy a Fortinet switch only to communicate them each other. If you remember or if you have read somewhere in 90s, if you buy a computer of Microsoft, you have to buy Microsoft mouse, Microsoft keyboard and Microsoft monitor to connect with the Microsoft CPU. If you buy any other company's components, it will not work. Likewise with the IBM computers also. Okay, now we'll understand what standards are. Standards based protocols are developed and maintained by standard setting organizations to ensure compatibility and interconnectivity of different devices and platforms. So first example is IEEE standard, which is 802.11 for Wi-Fi. This standard manages wireless local area networking, which is Wi-Fi. Devices from different manufacturers should connect to the same Wi-Fi network because they all stick to the IEEE 802.11 standard. Second example is IETF standard. which has IP, TCP, HTTPS, FTP. The Internet Engineering Task Force, which is IETF, develops and maintains these protocols. So, first is IP, which is Internet Protocol, which manages how data packets are sent across networks. Second is TCP, Transmission Control Protocol, which ensures reliable transmission of data between devices. Then is HTTPS, Hypertext Transfer Protocol Secure, which secures communication over the internet. And FTP, File Transfer Protocol, which is used for transferring files between computers on a network. Coming to next, how standards are maintained. RFC, Request for Comments. What is RFC? These are documents published by the IETF that describes methods, behaviors, research, or innovations applicable to the internet and networking technologies. They serve as the official standards for many internet protocols. An example of an RFC, RFC 791, which defines the internet protocol, that is IP, specifying how data should be packetized, addressed, transmitted, routed, and received across networks. Coming to next slide, before we start for protocols and layers, first we will learn about OSI layers. OSI stands for Open System Interconnection. This model is a conceptual framework used to understand and design how different networking protocols interact. It divides network communication into 7 layers, each with a specific function. To understand this, first we will discuss why OSI layer came into place. The OSI model was developed in the 1980s to address the growing complexity of computer networks. Before the OSI model, networks were often proprietary and incompatible, making it difficult to connect different systems. Okay, I will give an example for each layer so that you will understand it. Imagine sending a letter to a friend. The OSI model is like the different steps involved in getting that letter from your hands to your friend's mailbox. First layer of OSI is application layer. This is like writing a letter. It includes things like creating the email, browsing the web, or using applications. Examples of application layers are email, web browser, FTP, SMTP, etc. Second layer is presentation layer. This is like putting the letter in an envelope. It formats the data so different systems can understand it. Example of presentation are encryption, compression, image formats like JPG, GIF, etc. Third layer is session layer. This is like deciding when to start and end the conversation. It establishes and manages connections between devices. Examples: establishing a phone call, ending a file transfer, etc. Next is transport layer. This is like making sure the letter reaches its destination. It ensures data is delivered correctly and reliably. Examples of transport layer are TCP and UDP. In this, TCP is reliable and UDP is unreliable. I will explain this in next video. Fifth is network layer. This is like addressing the letter. It determines the best route for the letter to take. Examples of network layer are IP addressing, routing, etc. Coming to sixth layer, which is data link layer. This is like putting the letter in an envelope with a return address. It prepares data for transmission and handles error. Examples are MAC addresses, error corrections, switches, etc. And the last is physical layer. This is like physically mailing the letter. It deals with the physical connection between devices. Examples are Ethernet cables, Wi Fi signals, hubs, etc. This OSI model helps us to understand how complex networks work by breaking them down into smaller, easier to manage parts. Guys, for OSI layer, I will make a specific video and then you will understand the importance of it in networking and security. Now, let's come to the multiple protocols and layers. In the world of networking, multiple protocols are used to perform different tasks. Each protocol has a specific job to ensure data is transmitted correctly and efficiently. Think of protocols as different languages or sets of rules that devices use to communicate with each other. To manage the complexity of the networking, the tasks are divided into layers. Each layer has a specific function and communicates with the layers directly above and below it. This is often referred to as the OSI layer, which has 7 layers. So, right now, let's come to our next slide, which is encapsulation and decapsulation. A process of adding extra information around data on a particular layer is the form of header and trailer is called encapsulation. For this, I will give an example. Consider you are writing a letter to your friend. So in letter you mention from to your address, friend's address, and because of this information postman will understand where to deliver the letter. Similarly, in networking, header and trailer is a form of information where the device mentions from where the packet is coming from and where it wants to be delivered. Okay, now coming to decapsulation, a process of removing extra information, that is header and trailer, from data on a particular layer is called decapsulation. Let me overcome your question here. Consider this is your computer and a router is connected to your computer, and this is your friend's computer and his router, and in between is a large WAN network where suppose there are 7 routers. what your router will do, it will take the smallest path or the least router path. Correct. This is a path which is smallest among. Okay. Now you send a hello message to your friend. This hello packet is transferred to your router from your computer. Then your router will add information to it, which is nothing but encapsulation. Got it? And this packet is forwarded to another router which is located inside the WAN network. And then that router will send to another router with some more information added. Then to another router with more information added. And finally, it is transferred to your friend's router, where the router will remove the unnecessary information from it, which is decapsulation, and the main hello message is forwarded to his computer. Hope you have understood everything. Coming to next slide, let's discuss encapsulation in deep. It is a process of adding control information as it passes down through the layered model. Coming to the diagram, consider you are writing a letter. So the message you write is data. Then you put the letter in an envelope, which is a segment header. Then you put the envelope in a bigger package for some security, which is adding one more header to it, which is packet header. Then adding your address name to it, and where and whom you want to send is header and footers. Coming to decapsulation, it is a process of removing control information as it passes upwards through the layered model. Now your friend receives your package. First he will see where it is came from and removes that part which is removing headers and footers from the package. Okay. Then he opens the package which is removing packet header. Then he opens the envelope which is removing segment header. And finally he got the letter which is data. Okay, this is how network works. So this was it for today's video. Hope you have understood all the topics we discussed today. If you have any doubt regarding this concept, comment down your questions below. I will answer it. In our next video, I will explain you OSI layer in deep, and after that we will learn about binary math introduction. So don't forget to subscribe to my channel and press the bell icon for such informative videos. And if you like how I explain, please hit the like button. Thank you and have a good day.